So when you're doing Gaussian elimination, you can do any damn thing to the rows that you could do to equations. That's all they are. Rows are equations, yeah. So if I wanted to solve, see if I make one that works real quick. Good job, Jeff. Shit, I already forgot what it was. That's right. That should work. Okay. So very quickly, this should have been a two-step deal. What's my goal? If you don't know your goal, you're never going to get there. So what's my goal? 1, 0? 0, 1 with blah, 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 numbers. Okay.
Question?
Yeah.
So the y value is the second word, and the x value is the one on top, right?
Yeah, so this would have been x plus 2y equals 5.
Okay, yeah, because I got my one on the bottom, my 1 over 1 0 on the bottom, and then the y on the top, so I just...
It doesn't matter.
Yeah.
It really, as long as you have just one letter left in each row, you can tell what they are.
And then I
Yeah.
put,
I'm with you. So very quickly, what would be the first step here? I mean, if I start in the first column, I want a 1 here and I want a 0 there. Ones are nice, zeros are necessary. How do I make a 0 show up here?
You multiply the first one by 2.
Yeah, 2 row 1 plus row 2 in row 2. So if I double the first row and then add it, 2 minus 2 is 0. 4 plus 3 is 7. If I can read my own writing, 10 plus 4 is 14. Right? You guys, is everybody? So I saw like, and please don't get me wrong. I understand. This is new. It's weird. But I saw way too much writing. This one, I just got to make 2 zeros total. I need a 0 there. Got it. I need a 0 there. I'm going to get it. What can I do to make that easier? I don't want to work with the 7 and the 2, but thankfully, row 2, what can I do?
Divide by 2, or 7.
Divide by 7. So I get 1, 2, 5, 0, 1, 2. And now I can use that row to kill that 2, right? You guys kind of with me? I multiply by negative 2, add it. Okay. So it should just been a couple steps. Yeah. Okay. And again, it just takes some practice, right? And I understand. You're like, dude, I got chemistry, I got English, I got all this shit. I understand. So if you haven't quite gotten the homework yet for this stuff and you haven't gotten the practice yet, okay, you got time. You got our finals on Tuesday, the first day of the final, right? Okay. So what I want to do today, unless there's any other questions, I want to talk about. I want to do a real quick little thing about what we just did, and then I want to talk about chapter 13. And right now I don't remember what the hell we did yesterday. I have way too many things happening. Yes, okay. We did conic sections yesterday. So if you weren't here, dear God, watch that video. Can somebody tell me, could somebody figure out, stay with me now. What shape would that be?
Ellipse. Circle.
So I have some votes for
Well,
ellipse.
because ellipse, we have to make it into a 1 right there on the...
So in order to figure out how to graph it, I have to do some shit, but I don't need to do a damn thing to tell what that shape's gonna be, right? How do we know it's an ellipse?
Because the x and y are not the same. It's squared.
The coefficients are the same,
Coefficients.
and they're both the same sign. That is an ellipse the way it currently is. Do you guys all see that? Then I gotta do some shit where we're not gonna do, because this is a gross one, but I just wanted.
They're both the same sign. Like they're both
You ready? You ready? You ready? So this is an ellipse. If I make one change, anybody know what that is?
Hyperbola?
Hyperbola. Hyperbola.
Because it's minus sign in the.
Because now it's 4y squared minus x squared. That's hyperbola. Hyperbolas are unbounded because they're the difference of two positive numbers. And if I say the difference of two positive numbers is something, each number can be as big as it wants to be. That's a hyperbola. That's the idea. That's why the hyperbola goes to infinity. Or to infinity like that. Right? Doesn't quite get there, but yeah. In spirit, it gets beyond. You guys with me at all on that? You guys with me? Okay. So they give you this. No, Jeff. Let's not make it too gross.
Ellipse.
What shape would that be?
Hyperbola.
It'd be a hyperbola. Why?
Because of minus.
Because the minus. What are the two main ways a hyperbola could look? It could be like this.
Like this?
It could be like that. Yeah. It could be this or that. Right? Okay, I like it. Which one is this? Which axis would this sit on?
The y.
The y-axis, because that's the positive term, 11. This problem would probably be about the worst of all the problems we did. And here's why. It's hyperbola that's been shifted, yes? Where's the center of this hyperbola?
2 to the left.
Yeah.
1.
So the center's right here. How far am I going to go in the y direction away from that center?
3.
So is that cool? That's 3, right? That kind of, I know I say this a lot, but that kind of kicks ass. The number that's with the letter is related to how far you go in that letter's direction. That's crazy. That's squared, so it's 3 that I go in the y direction, away from the center. So if I go up 3, 1, 2, 3, and down 3, you can do it. My scale sucks again, but we're all going to be fine. 1, 2, 3. Huh?
Why is the center negative 2 and 1?
Because it went back to up 1. Yeah, see, that's the x direction, that's the y direction. Yeah. Yes?
In the bottom number, you're supposed to like get the square of them, right? The square root, and that's where
The square root of this, yes.
and then that's how like up you go and
Yeah, because it's real quick. Never do this, but does everyone agree I could rewrite this piece like that?
yeah.
See, the top is squared and the bottom is squared, so I really want to know what that number actually is. So that number is actually a 3 that's being squared, right? That's why I go 3 up and down. How far am I going to go away from in the x direction? 2. Yes, because that's 2. I like it. So 1, 2. And again, we already said this sucker should look like, yeah, it should look like this, yes? Up and down. So I'm not going to put, so I'm going to go 1, 2, open circle. 1, 2, open circle. Because those are not points.
A box.
Then I make a box. What's in the box? Okay,
Nothing.
nothing. And then I make my asymptote. Asymptote.
And since it's on the y-axis, it's going to go
Yeah, so now it's going to open
up.
this way, and you have the guide to help you. And this way, you have the guide to help you. So if I would have made this plus and this minus, it would have just been here instead. Yes.
What would be like the vertices and the foci? That was like in the homework, so I'm asking. Don't worry about it. Or
The vertices are just these two.
oh, okay.
Isn't that what we call the vertex if you thought this was a parabola?
Yeah.
Now, real quick, doesn't this look like a parabola? Parabola. It officially does not have the right curvature. It could never be a parabola. It doesn't have the right curvature, let's be honest. So the vertices are literally what you would hope they would be. The foci I'm not going to worry too much about, but here's the nifty thing. Nifty. For an ellipse, it was c squared equals a squared minus b squared. For a hyperbola, it's c squared equals a squared plus b squared. So in this case, it would be 9 plus 4, square root of 13. Square root of 13 is rough, is like 3 point
2
something.
3. Are you gonna ask for that?
So I move away from the center 1, 2, 3 point something. 1, 2, 3 point something. That would be the two foci. And do you see how it's doing? Like I said, the foci, I love it. The foci is supposed to be foci, whatever. John. As it's coming at, it should bend around it. So it's kind of like, I love that. I should show that video of the guy with the cannonball coming at him, and you're like, so the closer it's getting, the more you're like, get ready for it. So it makes sense the foci are going to be outside because that's why it's curving like that. They want to curve around the focus. For an ellipse, the foci are inside. And that's why the equation is minus for the c squared a squared minus b squared. I'm not going to worry too much about that. We didn't have a lot of time to sit with this stuff. Was that hard to do?
Yeah.
To make the picture? It's all about counting over and around. Yes? Okay.
There's something, I can't remember what it is, but there's some kind of a rule about like which line the parabolas, not the parabola, the
You mean if they're going to go
hyperbolas-
this way or that way?
Yeah,
It's just this. Which one of these terms is positive?
that's it,
The y term's positive, so it's going to open in the y direction.
right.
Yeah, it's going to have y interception. Yeah.
And you're doing the open circles on the x-axis because it's not hard to get to, right?
Exactly. It's just to help you make the box. These are part of the answer. These are just part of the guide for later. Yeah.
And then anything with a negative sign in front of it, that means like there's no x-intercept or y-intercept?
Yeah. Just be careful. If I shifted this far enough up, it would have an x-intercept. Yeah. So if it's not shifted, we start from not shifted. So if it's not shifted, it wouldn't have that intercept. If I shift it, I can force it to have any intercept I wanted to, right? Okay.
It's just on that axis.
Yes. Okay. If I would have made that a plus, what would change? I just make that minus sign a plus sign.
An
Then it
ellipse.
would become, ellipse.
And then I would be done right here, yeah?
Yeah.
So it's really neat. There's always an associated ellipse with every hyperbola. You guys see that? There's like this internal ellipse that goes with the hyperbola. I like it. And it literally is, like I said, contained, uncontained. Yeah. All right.
Stops.
All right. Maybe. Yeah, I don't think I signed too many problems out of that. I think I signed it from the review, if I remember. I can't remember. Okay. So, I want to focus on chapter 13, our last chapter. Can you guys tell me what the next number is?
13,
Yeah, what's the pattern apparently?
adding 3.
Adding 3. I love it. So that would be 13. Now, to be very honest, that is the most obvious sequence, but there are other sequences. So I'm always going to want the most obvious one, but there's whenever I give you something, there could be multiple answers. Right? So if I don't give you enough information, like if I just put 1, 2, what could the next thing be?
Could be three.
Could be 3. Could be 4. 2 to the 0, 2 to the first, 2 squared. Yeah?
When you ask us, like, if it's arithmetic or geometric?
Say again?
When you ask us if it's arithmetic or
No, we're not going to have time to get into arithmetic geometry, which is too bad. All arithmetic, this one is arithmetic because I'm adding. Right, so this could be, who knows? So I have to give you enough information to really know, right?
Fibonacci sequence.
Sure, we're getting there. What is it about this sequence? What's the next number in that sequence?
81.
81. What's this based on? This is based on addition, this is based on...
Multiplication.
So this name, the name of this, which you don't have to know, is called arithmetic. Arithmetic because you're adding. Geometric because you're multiplying. It almost works. So arithmetic is based on addition. Geometric is based on multiplication. You don't have to know those words, it's fine. I just want to let you know they exist. So watch this. Shouldn't I be able to create like an equation? So what if I wanted to know the 87th term? Would that sort of suck to just have to continue the sequence?
Yes.
Shouldn't there be an equation I could create to tell me what the 87th term would be?
I'm sure
Okay.
there is.
There would be, yes. All right.
Wouldn't it be 3x plus
Well, let's see. What do you guys think it would be?
3x equals 87?
No.
It's the first term?
Another x plus b.
So let me help you out. So what's the first term?
1.
1. What's the second term?
4.
4. I added 1, 3, yes? What's the third term?
7.
7. Didn't I add 2 3s away from 1?
Yeah.
So if I start at 1, I'm going to add how many 3s?
87.
N minus 1. How many 3s did I add to get to 1? None, because that's where I started, correct? How many 3s did I add to get to the second term? How many 3s did I add to get to the second term? How many 3s did I add to get to the second term? 1. Just added 1 freaking 3, right?
Oh, I see.
Okay. How many 3s do I have to add from here to get to the third term? 2. Don't I always add 1 less 3 than the term I want?
Yeah,
So what will the 87th term be?
86.
Well, it's not 86. It's plugging 86 in, right?
Oh, well.
I think that's 259.
You plug in 86 to n.
So this equation, what do you get when you plug a 2 into this equation? What do you get when you plug a 2 into this equation?
6 plus
Yeah, 2 minus, no, come on, you guys can do better. 2 minus 1
4.
is 1 times 3 is 3 plus 1 is 4. What do you get when you plug a 3 in?
7.
Yeah, 3 minus 1 is 2 times 3 is 6 plus 1 is 7. So you get to the 87th term, I just plug an 87 in and I work it out. Yeah. So it makes sense. If a sequence is built on something as basic as add 3 until you go crazy, I should be able to create an equation that tells me how to get to the whatever term. I shouldn't have to write that many terms out, right? Okay. So if I give you, so here's how we represent terms of a sequence. So if I look at this sequence here, I would say A1 is 1, A2 is 3, A3 is 9. I would say AN would be 3 to the n minus 1. Let's see if you guys agree with me. Third term is supposed to be 9, correct? What do I get when I plug a 3 in? 3 squared is 9. Yeah. Third term is supposed to be 9, correct? Is the third term supposed to be 9? So what do I get when I plug a 3 in? I get 9. Yeah, okay. That's geometric, sure.
We're not gonna have to worry about that.
Oh.
Nope. Okay. So,
Wait, H? Is that H or N?
that's an N, yeah. If I give you, can you construct the sequence? So these are called sequences, by the way. Can you construct this sequence? What would A1 be? What would A1 be?
N plus
You
1.
just plug in a 1?
Yeah, I'm letting N be 1. So what would A1 be?
2.
2. What would A2 be? 3 over 2. Does everybody see that? So if I select a value for N, I plug that in. Yeah. Okay. So I can define sequences as a function. So you can actually determine which element you want to look at. So this could be anything. This could be anything. Any function of that. I could even have this. What's this sequence? What's that sequence look like? Every single element is 3. Everybody on this planet is good. So 3, 3, blah, blah, blah. That one's just 3 no matter what I make in. What's this? 3. Yeah, so that's one of the more exciting sequences. Yeah. Okay. the most important thing I want to talk about from chapter 13 is the idea of adding sequences, elements together. So if I wanted to add, can anybody tell me what this sequence, what these elements are?
They're squares.
They're squares.
Perfect square.
So this is n equals 1, n equals 2, n equals 3. In fact, let me be better than this. I'm going to call this I equals 1, I equals 2, I equals 3, I equals 4. Yes? Jeff, fantastic. I love you, Jeff. Okay. I decided 16's had enough. It was 25 star, but not yet. So there's a, can you imagine if I kept going forever? I'd like a concise way to write that. So there's, what's the official name for adding things? What's like the official name for multiplying things is the product. What's the official name for adding things? Sum. The Greek letter S is,
Sigma.
looks like an E, sigma. I love it. So we chose this symbol to mean add up a bunch of shit, right? So this symbol by itself means the same thing, kind of like this symbol. If I say do this wouldn't make any sense, correct? Square root of what, Jeff? If I say do this wouldn't make any sense. Add up what, Jeff? So I want to add up I squared. Do you agree with me that every single one of these, the devil inside, no, Jeff, I squared is each one of them. You guys agree with me? And where do I want I to go from to? I want I to start at what number? 1. And I wanted to go up to? No, I want I to go up to 4. The square is going to go up to 16, but that's what I do with I. So I can represent the sum of any numbers that have a pattern to them with this. So again, this letter is sigma. This notation is summation notation.
We're gonna see that in calculus.
You're going to see this in calculus. This is one big reason why I have desperately got to make sure I talk about this.
Are we using the I as an imaginary number?
No, I'm sorry. Great point. We use I because the name of that the name of this is the index.
Okay.
So that's why we normally use I, J, K for that. I know, it's fantastic. Math, we only got like 26 letters, unless we use Greek and then everybody freaks out. So we use Greek a little bit.
There's only 24 letters in Greek.
But at least it adds to our 26, so now we got 50. It's crazy.
Makes 50.
Okay, so watch this. So we got that?
Almost.
I'm sorry. Just that almost sounds like too bad.
Oh, that's okay. Do this.
So, can you figure out what this is?
Did you just plug an I?
Don't say anything. Answer me this question. How many terms are we going to add? What's I go from to?
From 1 to 3.
All right, how many terms are we going to add?
Okay.
3. 1, 2, 3. Right? So you got to figure out what each term is and then just add them up. So one thing you can do for yourself, if you want to, I is 1 at first. So what are we working with if I is 1?
Maybe 1.
-1. Plus, what are we working with if I is 2? 0. Plus, what are we working with if I is 3? 1. Zero. Okay. So let me write this down. You guys do this one.
So we're working with 5. So the top one means we're working 5 terms.
No?
Bottom.
How many values can I have in this expression?
3.
3. So you're going to work with 3 terms here. You're just starting with I equals.
Five.
You're starting with I equals
Oh.
3, going up to I equals 5.
Alright, so
Oh, that's all that.
the bottom is sort of like the minimum and then the top is the maximum.
Totally.
Oh.
This is from 2. So we went from 1 to 3. So that idea doesn't change. So here I want to go from 3 to 5. So I don't give a shit what this is when I is 1, because I don't have to worry about that. So what do I get when I is 3?
3.
Yeah, I get 12 minus 9, 3. What about I equals 4?
Okay.
Yeah, 4 times 4, 16 minus 4 squared is 16, 0. I equals 5. 20 minus 25, negative 5. So I get negative 2. Right, 3 minus 5. So all this says is, this is a little function. You get a bunch of outputs. And this symbol means add them.
What if it's like I equals 25 and go all the way through 50? Like, you're supposed to add all 25 of them?
Yeah, of course. Yeah, but I'm not going to do that. That would just be busy work. But just not to freak you out, but just to show you. This is my differential equations practice final exam answer key. And this is the last problem on there. Does that look familiar? What would this mean? Don't freak out. Just look at this piece. Just look at that. What would that mean?
That's infinity.
That says infinity, yeah. So this would go from
Negative
0 to infinity.
0.
Okay. So you're worried about doing like 26 things, right? Don't worry. I'm sorry. I don't mean to freak you out. I just want to show you the stuff we're learning today is going to show up in calculus. It's going to show up in every class after this, basically, or it can if it needs to, right? Don't freak out. But that piece looks familiar, correct? And it means 0 to infinity, and you're like, thank the gods I'm not taking that class. But they don't do infinite number of additions. They don't. So there's a lot more shit you can do with the summation symbol. We are just scratching the surface. Okay. What do you think? Is there anything else? No. So, now that I've kept you at rapt attention, chapter 13 is extra credit. Chapter 13 is extra credit. We're not going to have enough time to sit with this stuff, but I at least, when you guys take calculus, if you're going to take calculus, you will have seen this symbol before, and all it frickin' means is figure out the outputs, add them up. That's all that symbol means. Yeah. Bless you. Say again. On a bonus question, maybe. I would only put extra credit homework section problems in the bonus section. Yeah. All right. So let me ask this. Does anybody need the practice final? Anybody not get a copy of that? Oh. So we're going to start our review. Sort of. Let me think. Do I have one for me? This is my last one. I need this one.
Okay.
Okay. So, and really make sure that everybody gets this, including the people at home. Chapter 13, extra. So we have learned everything we're going to learn this semester. Just that much. That's it. So what I need help from you, we have today and we have Monday to review for the final. Final's going to be Tuesday and Wednesday. One thing I kind of like to do in general is to kind of review backwards with the more recent stuff and then go back. It's kind of weird, jarring to start at the beginning, right? But I don't care. If there's anything on the practice final you guys want to talk about, if there's anything from any test, any quiz, any homework, anything you guys want to talk about, any ideas you want to do example problems of, this is wide open to whatever we want to look at. Yeah. 12. Oh yeah, okay. Something like 12 is not easy for me to whip up on the spot, but let me think. Let me go to that section in the book maybe. Well, I mean, we could look at 12, but of course I'm gonna give you the answer key.
You're gonna give us answer?
Oh wait. I almost showed all the grades. What do you mean? Of course I'm gonna give you the answer key. That'd be so evil. Here, look at these. You'll never know what the answer is. No. Just like any practice test, I'm gonna give you the answer key. Yeah. All right, so let's pick one out of the book.
So I'm guessing 18 versus polar parametric problems, will that be on the extra credit, or that will be?
Well, that'll be on the test, of course, because we
Yeah.
did those. Yeah, yeah.
Alright.
Let's see.
Is this entirely gonna be the final, broken up into 2 days, or is it gonna be 2 different?
So like backside, front side and the backside?
What's the question?
Are we
Sorry.
allowed?
Go ahead.
Is this whole thing the whole final that we're looking at, or only
Yeah,
one
yeah,
day?
yeah. I think it's plenty.
Okay.
So I'm gonna. I think we already discussed this, correct? Didn't we already discuss the first day's gonna be no calculator stuff, and the second day's gonna be calculator stuff. Yeah.
Yeah. We didn't discuss this, but.
We didn't?
At least I didn't hear it.
Oh, okay.
Maybe I was.
Yeah, we did. Okay, thank you. All right. Thank you. I don't blame you if I didn't. It's been that kind of semester, yeah.
Can we use those basic like $1 calculators just for like addition and multiplication?
I'm evil. You should know that by now. Okay. So let's see. Let's pick a problem out. Let me see. Here we go. Perfect. Let's do this one. Number 29. Does that look okay? Yeah. Yeah, Jeff. Thanks, man. Okay. I'm gonna write it down. Okay, let me see. Is there any other one that's good here? No, they all suck. Dadgummit. Oh well, too bad for everybody. Let's see. Trying to find another one if we want to do another one, but these all suck here. Let's see. Yeah. Okay, there's more. So looking at this guy. Does anyone see something immediately that's kind of like in my way? If the whole point of this is to show that the right-hand side and the left-hand side are the same. What's in my way to be able to do that? What's fundamentally wrong with what the difference is between the sides? I need them to end up being the same thing. Okay, sine and cosine, sure, but more importantly, you mean the 2x? Yeah. Or is everything in there talking about the same angle? There's no way in hell that I can make the right side look like the left side if they're talking about different angles, right? So what's this screaming for here?
Break down.
Break it down. So I can use a double angle formula, right? And of course cosine is an asshole, so I'm not sure which one to use here necessarily.
Yeah, so, the first one could be two cosine, sine x.
Right, that's a double angle formula for sine.
Yeah.
Okay,
Then cross out the sine x.
okay. So we get 2 cosine x.
Minus, then we minus.
Now here's the issue. When you see cosine 2x, there are 3 things it could be.
Sine squared minus cosine squared, right?
Yeah.
Or cosine squared x, or 2 cosine squared x minus 1,
Sure.
or 1 minus sine, 2 sine squared x.
Okay.
So which one?
All right. That's part of the question. Which one do you think we should use? So again, guys, cosine 2x. It's cosine squared minus sine squared x, right? Or it's 2 cosine squared x minus 1, or it's 1 minus 2 sine squared x. One of those is screaming that it wants to be used here. Second. All right, let's try that one. Okay, let's see.
But you can't cancel out the, you can take it out, ooh, yeah, never mind.
So can't I break this up?
Yeah.
Now here you gotta be careful. What's here? What's gonna be here?
Ah, I see.
Does everybody understand what's happening?
plus
So I'm breaking this.
plus
Hold up,
one.
Philip. Hold up. I'm breaking this fraction down. So
Plus
there's the
one over
first.
cosine x.
Philip, hold on. Here's the first piece of this fraction. Yes. And now I want to get the second piece. And what's the second piece going to be? Plus 1 over cosine. So what happens here?
Squares cancel out.
What do you mean squares cancel
Or
out?
the cosine x.
1 cosine cancels. And what's 2 cosine x minus 2 cosine x?
0.
0. And what's 1 over cosine?
Secant.
Yes.
Where did the -1 go?
This one?
Yeah.
So I got minus 2 cosine squared x over cosine, minus -1, so plus 1 over cosine. Right? So I broke it up into this. One thing you could do for yourself here is do plus, negative, plus. So just change the signs. And then it's just this, bam, plus this, bam. So the first kind of level thing you look for is, are the angles all the same? Because that could relate to a double or a half angle identity, right? Along with that, you just look for any obvious identities. If I see 1 plus tangent squared a, 1 plus tangent squared a, what is that? What is 1 plus tangent squared a? Secant squared a. Okay. Now, of course, if you don't know your identities, you're not going to be able to do that problem. But you've got to know those. Let me see. I think I saw a different one we could do. Is everybody okay with that? So once you determine, okay, I got to rewrite this. So the sign's awesome. Thank you, sign. You only have one option. Good. Then I just think, which option here would help me the most? I don't want any sine stuff, right? This is like related to cosine. So I didn't want to pick one that had any sine in it. So of course we picked the one that only had cosine in it. Do you guys see that?
Can you say that again?
So there are 3 options for cosine 2x, right? 2 of the options have a sign in them. I don't want any signs. So I just picked the one option that didn't have any signs in them. Yeah. It could turn out that's the wrong thing. And then I see it and I go, okay, I'll go back and I pick a different one. Who cares? That's part of the process, is sometimes picking the wrong thing. I saw another one, but I want to make sure. Do you guys want to do another identity or you want to do something different?
Different.
I would do 14
All right, 14. What do you mean 14? From
from x.
Oh, from the practice test. Okay. Where'd I put it? There it is. Oh yeah. Yeah, look at this. This is a very math teacher kind of thing to do. This problem has like 5 or 6 parts to it. The very first thing you need to do is to transform this into an XY equation, right? When you see rectangular, I mean, kill all the r thetas and make them XYs. So, can somebody, the most basic thing you can do when you're trying to convert from an r theta equation to an XY equation is, are there any cosines or sines just kind of there by themselves? Because what do you wish was in front of a cosine if you see it?
An R.
An r, because r cosine theta is x.
Or y. There you go, sine.
Sine likes y, cosine likes x, so Pictoa can suck it. So, do you see a sign? Do you see a sign that's by itself that needs an r? Do you see a sign that has no r in front of it?
Yes.
Yeah, totally. So, I want to give it an r somehow, and I can't just write it and go, I don't like your question, let me make another one, Jeff. How do I officially get an r to show up in front of that sine theta? Yeah, so go ahead and do it. Multiply both sides by r. Several awesome things are going to happen on the way.
So yeah.
0 R.
do you mean 0R?
0 times
Oh,
I is
0 times anything 0. Yeah. That's awesome. That's I just stays 0. So I multiply by R, I get this here, yes? What's R squared?
X squared plus Y squared.
4R sine theta? 3R squared cosine squared theta? What's R cosine theta?
Oh,
X, so what's R squared cosine squared theta? X squared. So you see what that's gonna be? Gotta be careful. What can you put together here?
Squared.
Yeah, so you get 4x squared plus y squared plus 4y equals 0. What shape is that gonna be?
Circle.
No.
Ellipse.
Oh, it's.
Ellipse. So it's not hyperbolic because there's no plus, but the squared x and y pieces have different coefficients. So it's going to go in different amounts in each direction.
So we're gonna have to make that 0 equal to 1.
Huh?
We're gonna have to make that 0 equal to 1.
Eventually. But before I do that, what's the very first thing I need to do?
You need to.
Are all my x stuff together in one term? Yes, x, you're awesome. Is all my y stuff together in one term? No, damn it, you suck. So why did I leave room here? Because complete the square. Okay, do it. Oh wait.
So we leave epsilon right now?
Huh?
So we should leave epsilon.
Yeah, he's cool. So the x is not shifted in this one. Right? There's no other x piece to bring in, so it's not been shifted. The y's been shifted. That's what we're trying to figure out right now is how much has it been shifted.
Where did the y squared come from?
What's r squared?
Squared is x, right?
R squared?
Oh, okay, it's y too. Sine?
So r cosine theta is x. R squared is x squared plus y squared. So like it's been forever, yeah. X squared plus y squared equals r squared, yeah. Just Pythagorean theorem, right? So what do I add here? 4. Because half of 4 is 2 squared is 4, so I add 4 to both sides. What's half of 4?
Please.
Squared? Okay. Alright, let's have a little sidebar here. We'll come back to that in a minute. Alright. What do I add?
It's beyond hilarious.
What do I? Thank you for your patience. What do I add so that I can factor this like this? There's 2 steps. Take half a 6, and then I square it. So y squared is the question, right? Well, one thing is you can see it works, but the better answer is if I take anything, any binomial, square it, I'm going to get x squared. The middle term is going to be twice this, right? Minus 4x. And the last term is going to be this thing squared, yes? So if I take half of the middle dude, I figure out what this is. If I square it, I figure out what this is. Done. Yes. Okay, cool. That is why complete square works. Now, somebody said earlier, now you can think about what you said earlier. What's wrong here? I need this to be
1.
a 1.
Divided by 4.
Divide everything by 4.
Now, when you get x on one side, is x squared? Oh yeah, x squared. So x squared, would that be -1 or 1?
So it's over what?
It's over nothing. It's over 1.
There you go.
Oh,
Yes.
Do we always have to have a 1 on the other side?
Yes.
So
Or just for that specific kind of problem?
for hyperbolas and ellipses. And the reason we do that is because then the 4 goes with the letter. Then I'm going to move that much, that we're going to move 2 in the direction of y. So we just chose to do that because then everything kind of lines up perfectly. Yeah.
And that's just called, that's the quintessential form, right?
Yeah, this is standard form of the ellipse.
Because of the plus.
So where's the center of this ellipse?
One up. Well,
No, come on. Has the x been shifted at all?
No.
Nope. So 0,
Zero.
-2. Cool.
That's my question.
Zoom way. Ah! Okay. This lesson brought to you by the Optometrists of America. Okay, here. So I'm going to plot 0, -2. That's not plotted, but the little C for center. In the x direction, how far am I going to go?
You're gonna go 1.
1. In the y direction, I'm going to go how far? 2. So up 2, down 2. Whoops. Start here, Jeff. Down 2. You can get your little. Whee! Okay.
That was it?
Yeah.
Cool.
Ooh, okay. All right. What about the so for the last problem, what if we do a partial fractions or
Yes.
okay.
I don't like
Huh?
I like those.
Oh man. Let's see. If I just make one up, it's going to be horrible. All right, hold on. All right, that'll work. Yeah. Oh. There we go. Okay. So let's do this one. 3x squared plus 2x squared minus 3x plus 2. That's neat, Jeff. All over x squared plus 1, x minus 1. What am I doing? Okay.
Why would we?
3x squared
It's a
minus
little
3x
different than the one that we
plus
have
2x
on
squared
here.
plus 2. Okay.
Okay.
Say again?
It's a little different than the one that we have on here, but I can see what we could do with the one on here.
Yeah, the one you have on here, you just have to first factor the bottom, and it's just grouping, right? Yeah, no big deal. Okay. So, the most important step is for me to realize I can add these damn things together. Okay. Let me try this again. 5x squared minus 3x plus 2 over. Okay, so that's the problem that you're given. These are the hands. No. What would the answer look like?
A
Maybe.
or
What's going to be on the bottoms? Let's do that first.
x squared plus 1,
So there's x squared plus 1 on the bottom of that.
and then x minus 1.
Okay, now. Do you want to or can you factor this any further?
No.
So you can't reduce this thing any further, so it's irreducible. So what degree is it? Second degree. So what kind of thing has to be on top of it?
Ax plus b.
Yes, so first degree, so a linear ax plus b. Something I just realized that is really silly that I've never in my entire life realized is whatever number that is how many terms you're going to have. Way to go, Jeff. So if that was a 3, you should have 3 terms. Ax squared plus bx plus c. Neato. What's going to go over this guy? C. C.
Can you explain why we need to have C?
Why we need to have C?
Yeah, because we already have AX plus B, and then we have plus C.
So you're trying to, are you saying that this could create this?
No, I'm just trying to understand why it can create that.
Oh,
There's a problem.
that's, so then you're saying, okay, so you're saying that you think this could create this.
I don't,
I could come up with numbers for A and B that it would end up being this. Is that,
no, I'm just trying to understand it, like why, yeah, sure.
okay. If I make A and B any number at all, the bottom is gonna be what? No matter what numbers I put in for A and B, what's the bottom gonna be? Why would it ever become this? Does it make sense? So I need to have another fraction that has an x minus 1 on the bottom of it. That's the only reason this would ever be this. So I already know C cannot be 0. Could B be 0?
Yeah.
Yeah, it could be, but I don't know. I gotta cover my x. It could be anything. So what's the first step here?
And we'll take the LCD, multiply it.
Yeah, so multiply both sides by these. Here's the shortcut. Whatever's on the bottom already is going to cancel, so it's just going to pick up the other dude. So here, if I multiply by this, these will cancel. It'll pick this up. Here, these will cancel, so it'll pick this one up. You guys see that? So if I write that next to it, because I'm just multiplying both sides by this can't die, so that's still there. This dies, so that's still there. Just remind you that the one little trick you could do that you can kind of cut down on some of the work you have to do. What would you let x equal? What would be a really cool value for x?
1.
1. If x is 1, I get 5 minus 3 plus 2 is 4. This is 0, yes? If x is 1, this is 0? So then I get c times 1 plus 1, 2. So I know c is 2. Yeah, see, that's nice. So hell yeah, I do that anytime I can. What would I need to make x so that this goes to 0? I'd have to make x I, and I don't want to. I don't want to do it. Can't make me. Okay. We're pretty much out of time, but just the next step would be, do you see how that's ax squared? Yes? If you FOIL this out, that would be ax squared, yes?
Plus A minus A.
Ax squared plus bx minus ax minus b plus cx squared plus c. So if you multiply all business out, what must a plus c equal?
2.
No, what must a plus c be? They're in front of x squared, correct? So what must a plus c equal?
5.
5. We know c is 2, so a must be 3. Kick ass. And then you can do the same thing for b. You can what must b minus a be? What's b minus a?
3.
Negative 3, and then you can do the same thing. B minus a has to be negative 3 because they're the coefficients of x. So of course when you put them together, they're supposed to make negative 3x, so they have to be negative 3. And you already know a is 3, therefore b is 0. So I get ax plus b over x minus 1, and then plus c over x minus 1. That's just taking this, that's the answer. Once I figure out what all my A, B, C's are, I can write the answer down. Okay, that's plenty. So Monday I'll have the answer key for the practice final. Monday's our last day of review for the final, and the next 2 days are final.
You don't have it now?
Huh?
You don't have it now?
Have what now?
The answer key.
No, I do not. Yes. So I'll have that on Monday.